Hi everyone, my name is Naman and I'm here to present you my project cover letter generation. What if I told you that you could generate a professional personalized cover letter in under 2 minutes? Today I am going to walk you through an AI powered cover letter that I built using cutting edge technologies like Lane Graph Agents, Fast API, Next.js, and a fully automated AWS deployment pipeline with blue green deployments. Let's first start with a big picture. Uh, this application follows three-tier architecture: front end, which is in Next.js, and I use app router in that. It handles user authentication through Supabase and provides a beautiful chat interface and manages resume upload. User can select their preferred AI models, whatever that's Google Gemini, Claude, or OpenAI. Tier 2 is back, which is Fast API plus LangGraph. The backend is where the magic happens. It's a fast API server that hosts my LangGraph based agent. This agent doesn't just blindly generate cover letter. It has a sophisticated workflow that asks clarifying questions, analyzes your resume, and crafts personalized content. And for database, I am using Supabase, which gives us PostgreSQL with a row-level security and user authentication and file storage for resumes all in one platform. Now let's look what our agent is. So our agent name is cover letter agent, and this is the workflow. So first of all, it will analyze the input and it will ask questions like others use like user needs to provide more information, o- or like a user ask a question and it needs a counter question, or anything else. And then there is a content agent. This node will create the content for cover letter, and this node even uses DuckDuckGo searches to look up for the company information, making cover letter more relevant. And step 4 is latex validator. The generated contents go into for formatter agent node, which wraps it in a professional latex template. User can even customize this template. And then there is a validation loop. Finally, like we have a latex validator node that checks the output. If there are latex errors, it automatically loops to latex fixer node to correct them. And this is self-healing capability ensures that you always get a va- valid document. Now this is where it gets really interesting for DevOps perspective. So everything starts from our source repository where code is pushed. Code pipeline orchestrate the entire deployment. Code pipeline orchestrate the entire deployment, and code build compiles our Docker images, and it will push that Docker image into our ECR repository. In this ECR repository, we have multiple versions of our image, and there is one latest image which will be deployed on ECS. Only latest will be deployed on ECS. So, and I am using ECS with Fargate for containerized deployment. but not in deployment. We have blue green deployments here. You see these two path. Blue represents our current production and green represents our new version. The application load balancer routes traffic between them. How does blue green works? When deploying version 2, ECS spins up a green environment with new task. Code deploy manage the traffic shift, and it can do instant cutover or gradual shift like 10% every minute. If anything goes wrong, we can instantly roll back to blue. And there is health monitoring. CloudWatch monitors everything: custom metrics, health checks, alarm. If green deployment fails, he- health checks, automatic rollbacks kicks in, and SSN topics notify us. Now let's view the API backend APIs. So these are the backend API. So I have different APIs for everything. I have resume upload API, to do chat with AI agent API, user API, and latex APIs. Also, these are different schemas. So let's look at our app. I will do a lookout. Yeah. So for user need to create an account. I already have account, so I will just do a sign in. So this is my old resume, and user will have user can see all the resumes that he has uploaded. User needs to provide a API key for Gemini. You can get this from aistudio.com. Now I want to upload new resume. I will click here and I will upload a new resume. This is my latest resume. You can also see the date and time. Now user can select different models here. For now there are three models only. I am going with 2.5 flash, and user just needs to provide a job application right now. So I'm copying this job application. It will take some time to generate, and user has different modes also, like there is a dark mode and light mode. User can also give a template in latex. Right now I am using default template only for this demo purpose, but this is fully customized. And so here you can see it will also do a Google search using DuckDuckDB, and it will provide latest information like your recent achievement in August 27 2025. So this is the cover letter. User can download this from here or this code. And if like user wants to change anything, let's say I want to change date here. Today is 15. It will also do changes in this. So this is for like quick editing. Like sometimes LLM hallucinates and generates something else. Like this LLM generates for cover letter for consultant, but this is for software development. So I can go here and change cover letter for software developer, and I just hit recompile and it will generate a new resume. Sorry, cover letter. And now for AWS part. So these are my ECR registry. I have two models, backend code and front-end code. Backend is in fast API and where all the magic is happening, like how agent is generating and validating latex code and everything. And this is the front-end code. I also use this to do a blue-green deployment. As you can see, this is 2.0. In later, I will show you a clip how I done a blue-green deployment, and it shows how traffic is handled. And my front end is deployed on ECS. So this is the front end cluster. It has front end service in it, and there are different tasks. Here are the memory utilization and CPU utilization. And my backend is running on EC2. So this is my backend code. What it will do is like for deploying my backend, I created a Docker image and pushed it on ECR, and then in EC2 I fetched that Docker image and run it inside this EC2 image, EC2 machine. This is network interface for front end and backend. Uh, I wrote a script to deploy this. I will show you a script after this. And I also set a cloud watch alarms. So for now, I set two alarms: front end service, 500 errors, and high latency. So it will check that how many times 500 errors are coming within 3 minutes, and its target response rate, like it is taking much more time, like latency is high or not. And this is the code deploy. Yeah, so this is the deployment group, front end service, blue green deployment. And in code part, uh, I created this deploy all.sh script. In this, these are some options for deployment, like you can do a backend only deployment, front end only deployment, update backend, update front end. If you select all, it will deploy first backend and then front end with the URL of backend. Like need to update the environment in front end for do, rec- doing REST request on my backend API. And also I need to update environment in backend for course. So uh, af- after deploying front end with URL of deployed backend, it will update the backend. Yeah, and it will update the course, and so our whole application is deployed. But if you want to deploy any specific part, you can deploy for front end, back end, and everything. Also, it has I set up a resume option. So, like if after some, let's say a step 6, you get an error, then you can continue from steps 6, and then you don't have to like rebuild the whole image and deploy it to ECR and everything else. And it will also give a nice summary. So this is the deployed summary. You can say this is my backend API and this is my frontend API. Yeah. Building this wasn't without challenges. First, the latex compilation is tricky, and I also have to build a validation fix loop that handles common errors automatically. Second, streaming LLM response while maintaining state required careful design of my message accumulation pattern. Third, blue-green deployments need precise health check configuration. Too strict and deployment fails. Too loose and you might miss issue. And I think one of the coolest feature is multi-LLM support. So you user can switch between Gemini, Claude, and OpenAI. These are like some major LLM API providers, and also user can use their OLAMA. Like if you have a if you upload your OLAMA API, you can use a custom your own own model or like a pre-configured model provided by OLAMA. Here is a demo for blue-green deployment. I triggered creating a new front-end version. This version is version 2.0.0, and it will uh, create a new image. It will use it will first of all create a it will load deployment configuration, and after deployment configuration it will load environment variables, and it will then determine new version, and it will get currently deployed version, and then it will upload this. It will build and push this Docker image to ECR repo, and after that it will also create a specification file for code deploy. You can see this is the app specification file. It has all the properties and load balancer info, and then it will provide us a link to track. Now let's open this link. This is the link. Here you can see the deployment replacement task and everything. Right now all the original traffic is on our previous version, and it is currently shifting to a new version. So you can see that here. It will take some time, around 10 minutes.